Hi. Hey guys, hope all is well wherever you are. I hope you're well mentally, physically, and I hope all of your loved ones are well as well. I said well a lot, but all right, that's neither here nor there. We're going to get into an example of explaining why two triangles are similar. All right. So we're going to do this through this example that you're seeing on my screen. So in this case, we're told that AB is, I don't know if you remember this symbol right here, but this means parallel. So I'm going to write this in words, right? So let's just write it in words. I always like to translate situations with symbols to words. So AB is parallel to EF. Why is this important, right? I don't know if you remember last year, or you may have learned it somewhere else. We covered situations where if two lines are parallel, you then and they're cut by a transversal, certain angles are created as a result of that. For example, alternate interior angles, corresponding angles, alternate exterior angles, right? All of those relationships come about as a result of two lines being parallel, and if they're cut by a transversal. So in this particular situation, we're told that AB, I'm going to put arrows here because this is how we denote that two lines are parallel. AB is parallel to EF, right? That's what we're told. As a result of that, you need to make a certain conclusion. So, let's just kind of put some arrows. So as a result of this, we can make the following conclusion. Angles E, B, and E are uh, alternate interior angles, and angles um, A and F are alternate interior angles. What do we know about alternate interior angles formed by parallel lines cut by a transversal? Alternate interior angles are congruent. All right. So we could say the following. And by the way, I'm in Jamboard and I'm just using this sticky note feature. So angles, we already have these arcs by A and F to denote that they're congruent. Angles B and E are also alternate interior angles, therefore they're also congruent. Now, if you're wondering, there's also, even if you didn't catch one of those pairs, you can also mention this. These two angles, do you remember the name for this? Give you 10 seconds, right? When two lines are formed, two intersecting lines um, occur, they form certain angles. What are these angles called? Anybody? Yep, you guessed it. Little birdie whispered in my ear. These are vertical angles. All right, you should remember that concept as well. When two lines intersect, when they form an X, vertical angles are formed. And all vertical angles are equal. All right. So I hope that was clear so far. Now, as a result of this, we can make a conclusion. We can say triangle A, C, B. The order matters, guys. The order matters. This is a similarity symbol, the little curly line or squiggly line is what I call it as well. Triangle ACB is similar to triangle FCE. How do we know that? Right? Let me just add in triangle. How do we know that? How do we know that it has to be in this order? We know that it has to be in this order because A, angle A, is congruent to angle F. So notice they both come first. Angle C, right? ACB and ECF are both congruent as well, but also angle B is congruent to angle E. And notice how they both come last. So that's important, guys. The way you write your similarity statement is important. This right here is your similarity statement. And I'm going to add something in a moment. You always want to state why the two triangles are similar. These two triangles are similar by a method called AAA, or for short, AA, right? So the triangle ACB and triangle FCE are similar. We don't have to write similar because the similarity symbol is already there, by AA or AAA method or theorem. All right. So I hope that makes sense. You know, we covered 3 types of theorems. We covered AAA, we covered SAS, and we covered SSS, right? You want to use the given information to make a specific conclusion as to why the two triangles are similar. All right. So now notice they want you to find the value of x. Now we can set up a proportion. So based on our situation, right? So we have ACB is similar to FCE. We could create the following proportion: AC over FC. This is one proportion we can make. We just have to be consistent. Notice how we're doing the left triangle first. The left triangle over the right triangle. We have to be consistent. So now we're going to do, let's say, BC, or CB is the same thing, over CE. And last but not least, AD over EF. AB, pardon me, I said D. AB over EF. All right. Now you have to ask yourself which one of these makes sense. We know nothing about AC and FC. We know nothing about that. So we're not going to include that in our work. So now let's just focus on BC and CE. BC, we know, is 22. All right. CE is X. All right. And AB is 24 over EF, which is 14. All right. So again, we're just simply substituting what we know for BC and CE and for AB and EF. Let me just draw a line down here just so I'm separating this. All right. All we're doing is we're substituting. Now at this point, in order to solve for X, we have to, one of the ways we could approach this is by cross multiplying, right? So when we cross multiply, we're going to do 22 times 14. So we're going to, let me just get a different color. So we're going to multiply these two things. So we're cross multiplying, and we're going to multiply these two guys. So when we do this, we're going to get 308, because 22 times 14 is 308. And we're going to get 24x. All right. So now, what do we have to do to solve for x, right? In order to solve for x, we have to essentially divide, because 24 is being multiplied by x. So we're going to divide by 24 to get x by itself. And our final answer when we do the math is going to be, now you could write this as a fraction or decimal. They may say to round it to the nearest hundredth or the nearest tenth. In any case, I'm going to put it in different possibilities. So in this case, x is going to be equal to 77 over 6. This is one possibility, right? Now, if you wanted to write it as a fraction, you can do so. But they may also ask you to write it as a decimal. So let's say if they wanted you to round it to the nearest tenth, this is going to be, this is an approximate symbol, 12.8. All right. So that is pretty much it, y'all. I wanted to once again walk you through how to use given information to prove that two triangles are similar, and then set up a proportion based on our similarity statement to find a missing side. I really hope this helped. Please let me know if you have any questions, and we will go from there. Enjoy the rest of your day.